So a mathematical model can be broadly defined as some formulation or equation that, in mathematical terms, that expresses essential features of a physical system. In terms of how we could write this in a functional form, we could say that the A dependent variable, which reflects the behavior of the state or our system, is some function of independent variables such as space or time dimensions, parameters that reflect the system properties, density, for example, and also any external forces that may be acting on our system. Now, the exact mathematical expression of this functional form can either be simple or it can be complex. Just think of Newton's second law, that the force, the resultant force acting on an object, is equal to its mass, the object's mass, multiplied by its acceleration. Now this is quite a simple mathematical expression. We could also rewrite this to say that the acceleration is equal to the force divided by an object's mass. But what's really important is that this mathematical equation, it describes a process with respect to mathematical terms, and it approximates or idealizes something about reality. And this level of approximation, well, we as engineers can decide on what is appropriate for our application. So for example, if we were measuring flow in a river and the flow rates were exceptionally large, we wouldn't need to calculate anything to the third decimal point. And the last point is that this mathematical expression, in Newton's second law, it can be used by us to predict how something is going to behave. We can apply Newton's second law to, for example, evaluate how a body was going to fall through space. So we might have some object. This object obviously has some mass attributed to it. And we know from the functional form of Newton's second law that the acceleration is equal to force divided by the mass of the object, or the resultant force. And acceleration can also be written as the time rate of change of velocity. We can then use our scientific reasoning to deduce what forces are acting on the system. We know that gravity is acting downwards, and drag, or any type of resistance, is going to act in the other direction. Let's explore this in detail in the next section.